Greetings! Anton here with a hot dogs, horseshoes, and hand grenades devlog for you this week. We are going to be doing another deep dive into the process of making a level for H3 this week, in part because this is the largest level, well, not necessarily spatially largest, but definitely from a complexity standpoint and volume of content standpoint, this is the most complex level I have built for the game. Because of the fact that I have been basically spending the past 2 weeks, not just working on new kits for the level, but fighting with lighting, I figured it would be cool to do basically a deep dive on what are the processes involved in lighting a level that actually looks good in H3. Why is it so time consuming and difficult? And how does a bunch of that stuff impact how you make a level in this? And hopefully some of you modder folk who do custom levels for the game will also see a few of the things that I fight with, and that it will be sort of useful for you or any of you who are interested in making Unity games or just other indie games who would enjoy a look behind the curtain. So to start off, let's actually talk about the state of the level at a top end, sort of like what I've been getting done and sort of what my current thoughts are about the sort of size and composition of the level. So I'm going to just zoom out here for a moment. You will see I've got a whole bunch of stuff turned off because there are parts of this level that I do not intend to show in the devlog or even in the Discord or on my Twitter at all prior to it launching, because I want them to be a complete surprise, just to be so that you can have that aesthetic impact with them right the first time you play it. But I want to talk about sort of like the sort of scope of this level and a bit about its composition. So you can see here that we have this sort of central area of the level here. This is going to be the footprint of a couple devlogs back. I showed a transit station where there will be sort of like a sci-fi maglev train that can whip through, that if you're standing on the tracks, or if Sosigs are standing on the tracks, will just pulverize you. But I'm extending this concept a bit to actually using it as essentially a bit of a micro fast travel system in the level proper, in that basically there will be the sort of central transit area, which will be a hold point, and then there will be a north, south, east, and west sort of jump point in the level that you will basically be able to warp back and forth between that central area and these extents. And I'll probably do something fun and cinematic where you'll like hit a button and then you'll hear like a distant sort of train thing, possibly see some lights down on the train, and just boom, it'll come by like a bullet and instantaneously teleport you and sort of drop you off at the other station. And the reason for that, the reason that I want to do this in conjunction with a bunch of the other sort of decisions that I'm making here, is that this level is going to be significantly bigger than the hallways level that currently exists. About 2 and, like at furthest extent, about 2.5 times the sort of size on each of the lateral axes. And so I want to make sure that sort of 2 things are being done, which is efficient transit between areas of relevance in the level so that you don't just get bored running around hallways. And even more so, I want to make sure that the design of the level is helping reinforce for the player useful heuristics for like where stuff is relative to other stuff. So that, and this is one of the reasons why, as I'll talk about here in a second, there are going to be sort of like 5 quadrants to the level, a sort of a north one, a south one, a west, an east, and a center. So you slowly will learn the relationship between those. Each quadrant has a different style of hallway associated with it, and a different suite, sort of like loosely theme tied together supply rooms as well, so that even when you start right at the beginning of the level and you're in a given supply room, you can be like, okay, I'm roughly speaking in this part of the level relative to the rest of it. Just because the moment you sort of I've noticed like classic hallways, people can navigate that just fine once they get used to it. Whereas the old containment prototype, people just get lost constantly. And part of that is because that was a terribly designed level that I did while high as a kite on dental painkillers after oral surgery. Don't design levels in that state. But part of it had to do with scale, the moment you sort of get big like that. So I want to make sure that even though this level is scaling up, this is going to be more level than the hallways. I want to make sure that every design decision that I'm making helps reinforce making it conceptually manageable for people to navigate. So let's take a look at some specific stuff. So this is the sort of redux, the sort of remade version of the first set of hallways I showed off that had some wood inset that I had originally was sort of unsure if I was going to drop them or not, and I wanted to rework them. So here is the reworked version. I think this is far more sort of like tasteful visually, and more importantly, we have these sort of insets going down that provide cover. And so it makes it significantly easier to actually move down the hallway and advance towards a target that you're fighting, just in terms of the actual structure of the hallway. Note, these are not going to actually be completely empty like this. As I mentioned before, I'm not using the dynamic cover system at all for the holds in this level, which means that there's going to be a lot more props. There's going to be obstructions, piles of stuff, as well as some dynamically spawned props that'll be fun that I'll share later. They are in production. So yeah. So you can see here, this is the sort of central or sort of transit area, and an example of it hooking up with a hold room. And so here's one of our hold rooms, and we can basically see that one of its doors connects into the main hall. One of its doors connects down into a series of service hallways, which I don't have lights in all of these yet. And then the rest of its doors are, as I had mentioned before, oops, I don't have one up here, are fake, in that these will basically be closed when the hold is not active, and these purely exist as areas for bots to essentially spawn here out of view and run around and attack the point. So yeah. Whew. Here's an example of sort of like the transition between sort of the central hallway here and the north quadrants hallway. Looking very pretty. Oh, I need to, 1 second. Recording unpaused. Yeah, well, when you've got Steamworks stuff installed in a Unity project, Steam thinks Unity is a Steam game and will just occasionally draw various Steam notifications like so-and-so is playing a game over random sub pieces of the Unity editor. It's terrible. Anyway, so yeah, looking along, this is the north hallway set. Some of these pieces aren't actually baked. I was moving them around, but you can see that as I've sort of done this second pass on them, a bunch of the lighting has been altered or it's been cleaned up. In this case, the sub area for this hallway set has these sort of cool service lights to contrast the warm light coming in from the top. And this is a motif that I have tried to do over the course of both the hold rooms and the supply rooms, is that anywhere where there was an area that was a little bit too dim from primary illumination that I wanted to actually be brighter, I tried to add a hue contrast for that illumination. So in this case, we've got warm light from the top, and then cool light for a little detail area there, because I don't know about you, but I love just having those little hue contrasts visible at once. And it's one of those things that when you're in VR in this level, I personally think it's one of the reasons that it ends up tricking your brain in terms of being like, wow, this is a way more realistic looking space, because conceptually, just moment to moment through our day, we don't really think of lighting as being terribly colored, because we normalize to whatever the color temperature of the room that we're in is. We just think of like daylight as being white sort of thing, and most indoor light we think of as being white, when there's always a pretty significant hue coloration to it. So this level really brings that out, and I think it's one of the reasons why it tickles the brain in that way. Let's find another Is this one of the ones? Yeah, so in this case, once again, this is a cool light coming in from the top, warm light used for our secondary illumination. Isn't that pretty? You can also see with this layout that in addition to our primary hallways, we have this set of service corridors that connect pretty much everything via some secondary entrance. This one is going all the way in the north from a connection in this supply room all the way around here, forking and affixing itself into this hold room, coming down here, connecting to supply room, hold room, hallways, etc. And this is one of those things that I started to lay this out in part to see, one, how many service corridor tiles does it take to run this entire secondary route? And I'll be benchmarking this in a bunch of ways just to see if this begins to become a performance issue, because as I said, this level is a lot of pieces. But more important to that, there's also this sort of central design question of, is it a problem to have so many long hallways? Like, are these fun spaces to have engagements? Will you run into bots frequently enough? Or will it just be a lot of like running around and not enough things are happening? And that's something that I can try to imagine ahead of time as I'm laying this out, but I won't really be able to tell until I lay it out and set up some sort of synthetic tests where I forcibly trigger some of the take and hold game code, but in a limited context, to just see what that ends up being like. And that actually ties into some stuff related to game mechanics that I might talk about a little bit today. We'll see how long the rest of this takes. So yeah, so let's talk about lighting. Why is this so time consuming? What's going on? Like, especially because some of you who've been following these devlogs are like, hey, most of these spaces, a bunch of these hallway kits, a lot of these rooms are stuff that I saw a week or two ago. Why did it take 2 more weeks of work? And a lot of that has to do with the fact that getting one of these rooms to the point where I can take a pretty screenshot of it or walk around without dynamic objects is in many ways the easy part. Lighting in a game scene like this essentially has 3 components to it. It has the light map, which is what is used on all of the static geometry for our diffuse illumination, all of this pretty shading. It has what are called light probes, which are sample points of illumination, kind of, that look like this. And yes, these are, oh wow, that looks wild. Yes, these are, in my case, laid out by hand. There are automated tools that try to do this automatically, and they all have problems, largely due to the fact that light probes are terrible. And I'll get to why in a bit. But yes, so it involves, for each of these given types of tiles and rooms, laying out hundreds and hundreds of these points by hand and then diagnosing them, clicking the render button, waiting for it to finish, seeing how things work. And then actually, if you want to even more tediously, what one frequently ends up doing to diagnose them is you literally just like take a sphere like this and run the sphere along everywhere where you're going to have like dynamic objects or bots, and you watch the illumination change. You see where the tetrahedra ends up being. I should probably explain that. So the way these are efficient basically is that every single object is being drawn, that is dynamic, that moves around the scene, is being drawn with a weighted average of a tetrahedra of 4 of these points. And it works this way, I think, for performance reasons, in terms of making it really cheap to tell what are the 4 points that are most relevant to the object, especially as it moves through the scene. But there's a whole bunch of problems with this, as you might imagine. Like when you've got a dark area down here and a bright area up here, you have to place the probes basically perfectly, or you end up getting objects that are near that transition using some probes from the top and some probes from the bottom. This happens constantly, no matter how much time you spend carefully placing them, because there's no way to define, like, don't average points across these 2 volumes. because this is the Unity engine, and every single system they've ever made is just a reference implementation that they're like, close enough, and they move on to the next thing. So you can tell I'm just slightly bitter. But yeah, so the other thing that is a real pain about light probes is essentially like, what is this sphere? What is being saved? And I'm going to give a layman's explanation because no one wants to sit and hear about spherical harmonics math. But the easiest way to think about this is that sphere is a set of numbers that basically define a color intensity curve, almost like you were in Photoshop, that's been wrapped around a sphere in a bunch of different directions. The problem with that is that it's not like a light map where we can just define individual pixels for illumination, and those pixels can be as different from each other as you want. You can have two neighboring parts of a light map, and one of them is super bright up here and one is black, and there's no problem really. In this case, because we're using a bunch of constants to create this curve, it's a coarse representation that has been fitted to it from the illumination around it, which means that curve ends up getting warped by really, really bright things, which is a problem when you're making a brutalist level with really dramatic, intense ceiling light. And this can cause an artifact that is called ringing, which you can actually see if we bring this all the way up here to the top, where because it's so bright up here, it's like above 1.0 brightness, it ends up darkening the opposing part of the light probe darker than it actually should be. And this looks terrible on objects. And so I probably spent the entire first week of the last 2 weeks just laying out light probes and then being depressed because I couldn't get the result of dynamic objects near those things to actually match the aesthetic of the light maps, because the light probes could not hold the illumination information correctly and be translated to the objects. So I ended up having to essentially relight every one of these rooms with a different approach after the last time I showed them to you folks. And for technical answers, any of you who run into this in the future, the biggest change that I made was actually capping the intensity of all of my area lights much, much lower than I was doing. Essentially, I was relying on primary illumination from my area lights to fill the scene with light and a sort of standard indirect intensity. And to prevent ringing on my probes, I had to bring the intensity way down and artificially boost in what's called a completely non-physical way the global illumination multiplication for the light. This bothers me because this is essentially super wrong to do this from a lighting math standpoint. But as long as light probes function the way they do, this is basically what is necessary to, if you're trying to light a room this way, and not have terrible results with your light probes. So, being a game dev is so maddening. Now, the third part of layer of light that we have to deal with in our scene is something called a reflection probe. And this is what gives us our specular reflection. When we pull out a 1911 and it's got that mirror shine on it, this is what is providing that illumination. And the way these work is they're a more complex type of probe. It's like a 360 degree shot of the scene from the perspective of that probe. So if I just grab one here, they don't really display correctly in the editor here, but you can see them right here. Oh, this one is, why does it just show black there? I think, yep, I baked these wrong. They are too close to the ground. Whoops. Let's find one that's not broken. There we go. So here's our 360 degree capture of the scene. And once again, for efficient rendering usage, what this basically does is that it stores the sharp version of that reflection And then it stores these lower resolution, blurrier and blurrier and blurrier versions of that reflection. And those are used for especially metallic objects that are metallic but rough instead of smooth. And it interpolates between these based upon how an object looks. So if I actually go in here and grab my 1911, bring this up here, zoom in, rotate it around. There we go. There's our 1911 with that, using that same reflection. We can actually rotate it, and it should, yep. Beautiful. Now there's some problems with this as well, which is that a couple things actually. The first is that essentially what we're doing is taking a very, very coarse picture of spatially of the reflection. This whole volume here is essentially using what the reflection looks like at that point and warping that reflection to based upon the position. It's called box projection of the object in that volume, which means that the further you get from that sample point, the less accurate that reflection looks. It's generally close enough. Most games do some version of this, that unless you have a mirror finish object, it works just about fine. But if you've got something that's like chromed, it can look very, very wrong. The second problem, which is Unity specific, is that whoever wrote this system back in Unity 5.0 or whatever basically decided that caching was for nerds. And so every single renderer, every object in a Unity scene, every single frame looks up and determines what its reflection is based from the number of reflection probes that are active, whether or not that object ever moves or not. And so there is a linear cost on the CPU per reflection probe, per object that can have reflections. It can sneak up on people because it isn't a big thing if things aren't very complex. But if you're like me and have, let's see here, T reflection probe, how many do we have? This is how many are in this scene, and this is just, you know, about a quarter of the complexity of the scene. And this many reflection probes all being active at once at a full complexity scene would actually be enough to probably like bury a lot of weaker CPUs doing a VR game. This is something I discovered several years into H3 and just wanted to tear my hair out. So essentially you need a whole custom culling solution for this, and I have to use less of these than I would really like. I would get significantly more accurate and sort of beautiful reflections if instead of using one long one for this hallway, if it was broken up like every 16 or 24 meters, but that would explode the number of these. And so part of what I'm doing with this layout test is for this specific content and this specific context and this specific level of light and placement of lights, finding out what the smallest number of reflection probes I can use in each of these hallway contexts and room contexts and still have it look nice. Just because all of those things tend to need stress tests, and the rule number one of optimization is it is always easier to just do less than to try to make the large volume of things that you are doing be cheaper to do. So boo. It stinks that so much of one's time is taken up with this. And how to put this? Just to sort of jump out a little bit to the why with a whole bunch of what I'm doing with this level and why I'm spending as much time as I am, why I'm getting as precious as I am with the design of this and making this as pretty as I am, is that, to be perfectly frank, for the 7 or so years of working on H3, I have had to have a priority list for content for the game that basically is, how does it function? How fast does it run? How fun is it? And then down here is how it looks. That has had to play fourth priority the entire time, because with VR, you have to hit frame rate. And if you don't hit frame rate, you make people sick. And to get things to run at frame rate, you have to do all of these absurd, constant optimizations to all of your content. And so for most of the, despite being a visual artist and being of that background, having gone to art school, most of the time that I have spent working on H3, I have not gotten to privilege aesthetics much. And so this was an opportunity, especially because I've had so many reps and so much practice with making these sorts of things run well at this point in H3's context, to do a piece for the game, to do a signature take and hold level that was an expression of what's important to me aesthetically, and being able to have a rare moment of actually being able to privilege that. So I apologize that it's taking as long as it is. Truthfully, it's been taking longer than I kind of expected it would, both because of technical difficulties and just in the, like, this is a lot of content, actually. The number of rooms, the number of tile sets, etc. This is already significantly more unique art asset content than the hallways level is composed of, and a lot of it is more complex. But I'll get a lot of mileage out of this. As I said, I'm still going to be building some sandbox levels from this when the time comes. Yeah, well, I think that's probably good for this week. There's some stuff that I'll probably talk about next week involving take and hold mechanics that I'll just give you a little hint of now. Basically, what I want to try doing with this level is making a couple of the aspects of take and hold feel a little more intentional from sort of a stealth action perspective. I'll go into next week what that will actually entail, but in short, I would like to make the take part of the take and hold more interesting in a way that I tried and failed to do in take and hold containment, because that was kind of a mess of ideas that didn't really cohere. So now that I know what I'm doing more, I would like to give that a second run and do it in the context of this level. But we'll talk about that next week. Anywho, I hope you have all found this little deep dive interesting and useful, and I hope seeing more of the level, especially seeing bits of it actually assembled and getting an idea of what its topology and size might end up being, is exciting to you folks. And I'll have some new content and hopefully a build for you next week, because we actually, I looked at calendar and I was like, oh no, 4th of July is coming up. I would like to do something stupid and actually have like a main branch release on 4th of July, because it's the most American of holidays, obviously. And so next week, I'm going to actually cycle us onto Alpha Branch with our replaced ammo models that have been going in, make sure I didn't break anything, and get us onto main branch so I can do something goofy and possibly explosive, probably definitely explosive for the 4th of July. So I wish you all the best. Hope you all have a wonderful weekend, and I'll see y'all soon. Peace.